Welcome students. Today we are going to start a very interesting and important chapter, complex numbers. This is very important chapter. We'll start this chapter with introduction. So here we will discuss what is a complex number, what are the different forms of complex numbers, and what are the related rules, formulas, problems. So let us start with introduction. The numbers of the form a plus ib are known as complex number, where a and b are real numbers and I is an imaginary number. I is equal to square root of -1. The numbers of the form a plus ib are known as complex numbers. Denoted by Z. So here we can write Z is equal to a plus ib, correct? Here a and b are real numbers. A and b are real numbers and I is equal to square root of -1. This is known as imaginary number. Okay. So there are so many examples. Suppose Z is 1 plus 2i, or Z is -3 plus 5i, or Z is equal to 2 by 3 minus 6i, etc. These are all complex numbers. Okay. Here a, which is real number, this is called real part. Here a is called real part of complex number Z and denoted by REZ. So REZ is here a, and B is called imaginary part of Z, denoted by imaginary IM of Z, which is here B. Correct? If B is 0, if B is equal to 0, then Z is equal to a plus ib. This becomes a. Then this is called purely real number, which is a purely real number. Is a purely real number. And if a is equal to 0, then the complex number Z, a plus ib, becomes ib, since a is equal to 0, which is a purely imaginary number. Now let us discuss conjugate of a complex number. Conjugate of a complex number. Okay. Suppose Z is equal to a plus ib. This is a complex number here. Then its conjugate is, this is denoted by Z bar, and this is equal to a minus ib. Here we are changing the sign of imaginary part of this complex number. So in place of a plus ib, we are writing here a minus ib. This is called conjugate of this complex number, and this is denoted by z bar. Correct? Next, let us discuss modulus of a complex number. If z is a plus ib, then its modulus is denoted by this notation, and we read it mod object, and this is equal to root over a square plus b square, real part square plus imaginary part square. This is modulus of a complex number. Suppose z is 3 plus 4i, then its modulus mod z is equal to square root of 3 square plus 4 square. We can simplify it further. 3 square is 9 and 4 square is 16, square root of 25, and this is equal to plus or minus 5. So modulus of this complex number is plus and minus 5. Now let us see equality of complex numbers. Equality of complex numbers. When two complex numbers are said equal, so let z1 is one complex number, which is a1 plus ib1, and z2 is another complex number, a2 plus ib2. Then these two complex numbers z1 and z2 are equal if and only if both real parts are equal. a1 is equal to a2 and both imaginary parts are equal, and b1 is equal to b2. Then these two complex numbers are known as equal complex numbers. Correct? Now let us discuss sum and difference of complex number. Sum and difference of complex numbers. In this case, we are considering z1 and z2. In the same case, z1 plus z2 is equal to a1 plus ib1 and plus a2 plus ib2, and this is equal to a1 plus a2, real parts are being added together, plus I into b1 plus b2. So here real parts are added together, similarly imaginary parts are added together. So we are getting sum of two complex numbers z1 and z2. Similarly, difference of complex numbers z1 minus z2, this is a1 plus ib1 minus a2 plus ib2. Here we are subtracting this complex number a2 plus ib2 from this complex number a1 plus ib1. This is equal to a1 minus a2 plus I b1 minus b2. Correct? Here difference of two real parts, first real part minus second real part. Similarly, difference of imaginary parts, first imaginary part minus second imaginary part of these two complex numbers z1 and z2 respectively. Clear? Now let us discuss sum and difference of complex number. Sum and difference of complex numbers. In this case, we are considering z1 and z2. In the same case, z1 plus z2 is equal to a1 plus ib1 and plus A2 plus IB2, and this is equal to A1 plus A2, real parts are being added together, plus I into B1 plus B2. So here real parts are added together, similarly imaginary parts are added together. So we are getting sum of two complex numbers Z1 and Z2. Similarly, difference of complex numbers Z1 minus Z2, this is A1 plus IB1 minus A2 plus IB2. Here we are subtracting this complex number A2 plus IB2 from this complex number A1 plus IB1. This is equal to A1 minus A2 plus I B1 minus B2. Correct? Here difference of two real parts, first real part minus second real part. Similarly, difference of imaginary parts, first imaginary part minus second imaginary part of these two complex numbers Z1 and Z2 respectively. Clear?